Hello, today we're going to finish up the Chapter 4 notes for intermediate algebra. We have to start with a little bit of terminology just to make sure we're on the same page and communicating effectively. So we deal with these polynomials with multiple terms. So a term is what we call this combination of letters and numbers, with some have powers and some don't. The number part of the term has the special name coefficient. And then, of course, we have the variable, which is the letter, and he will be raised to some certain power, which we will call his degree. Now, the degree of the entire polynomial will be determined by the highest power. Each of these terms is separated by a plus or minus sign, so we'll look through the multiple terms to see which has the highest power. We have some special names for polynomials with 1, 2, or 3 terms. 1, of course, is a monomial. 2 is the binomial, and then 3 is the trinomial. If they have any more than 3 terms, we just call them a generic polynomial. There's no more special names. So in this right here, we have, of course, that trinomial. Second. We have a trinomial. Now, if you had a picky math teacher in the past, they probably asked you to write them in descending order, where the powers would be going down in order. So we would typically put this one in the front. But even if they are not in what we call our standard order, we still have the leading term as the one with the highest power. So the degree of this polynomial, like we said, is the one with that highest power, which would be this guy right here. And his power is 3, x to the third, which means the leading coefficient of this polynomial, the coefficient is the number part of the leading term, which would be 6. So again, it's not about being front or back, because we know from our commutative property that we can flip the order up, but it's always about that highest power. This next one would be a binomial because he has 2 terms, 1, 2. The degree of this binomial be determined by the highest power. So if there's 1, 2 terms, this one has a power of 1, understood 1. This one is a constant, which of course doesn't have any variables. So the degree would be 1, the highest one. The leading coefficient in this case is in the front, but it's always attached to the one with that highest power. So it'd be a 3. Now this one down here is actually just a single monomial. You may not even think of him as a polynomial because it's just a constant, but technically he is a polynomial, in this case a monomial. The degree of this one, we saw from the others that it ends up being basically the number of the variables. This one had 3 x's in the term with the highest power. This one had 1x in the term with the highest power. So this one doesn't have any variables, so he actually has a degree of 0. Technically, he would have a x to the 0 power with him, because remember, anything to the 0 power is 1, and anything times 1 is itself. So it all works together. The power is 0 because there is 0 variables, which means the leading coefficient in this one is easy because there's only 1 term, and the 1 term is all coefficient. So it'd be the whole thing negative 3/4. So it's important to have this language settled because we want to be able to combine like terms. So what that means is we would go through and find ones that have exactly the same variables with exactly the same exponents. So for example, if you had an x squared and an x cubed, even though they have the same base of x, we could not combine them. They would not be like terms because they have different exponents. So in this problem right here, I have n to the 8th, n to the 8th, and n to the 8th. So they all have the same matching variable and power parts. So when that happens, I can combine their coefficients. Now think of them kind of like if they had been apples. I had 3 apples minus 9 apples plus 12 apples. Well, 3 minus 9 would make a negative 6. So we would go into apple debt. We would have negative 6 apples. But then when I put 12 apples into my apple bank, I have overcome the debt and I now have positive 6 apples. So notice during this whole process, the apples never changed because I was not multiplying. I was not changing my variables. I was just combining the coefficients and gathering them together. So it stays into the 8th. In this next problem, This one has an A, has an A, has an A, but this one, of course, has an A squared, and this one has an AB. So since these are different, we could not combine them. I also could not combine to the back one here, who has a B squared but no A, but these two in the middle both have a single A and a single B, so they would be considered like terms. If I have positive 8 and a negative 15, because remember the sign always belongs to the number behind it, that would combine to make a negative 7. So my final answer would be those two combined to make the negative 7. And then the first and the last would just follow you down. They didn't have anyone to combine with, so they did not change, but they are still there. So notice that I needed the signs between them to separate the three distinct terms. And notice also that it's not a squared, b squared, because I was not multiplying. I was just adding and subtracting those like terms. So if I needed to add two polynomials, if this had been a plus sign right here, you can pretty much jump straight to the step like we did in the red one where you're just combining like terms. But if there is a negative involved, you always need to be careful because those negatives are always sneaky. If I were asking you to take this whole polynomial minus this whole polynomial, that means I need to subtract each term of this polynomial. I need to distribute this negative understood 1. Each of these terms needs to be subtracted. So even though it might seem tedious, take this step on your paper. Don't try to shortcut and write this out with your new signs. So negative 1 times this positive 2x squared would now be a negative 2x squared. This positive x would now be a negative x. And negative times negative would make this last one a positive 7. So take the time, write this step. Don't try to just do one of these. You'll miss something, you'll overlook something, and you will make a small mistake, especially during the pressure of a test. So just take that time and write out this one line. Now we can go through and start matching things up. Here is an x squared. This one only has one x, so he doesn't match constant. But here's another x that matches up. So be careful with those negatives again. Minus 4 minus another 2, remembering that the sign belongs to the number behind it, combine to make a negative 6 x squared. Remember, not x to the 4th. I was not multiplying. Then I've got positive 5x's here, minus understood 1x there, would make positive 4x's. Make sure to put that plus there to separate your terms. And last, I've got minus 3 and plus 7 would make a positive 4. And that's it. So remember, these are expressions, not equations. You cannot solve them. That's as far as you can go. You're just cleaning up. This one here is tricky. He's so sneaky with those common mistakes that he would make a very good test question to make sure you were really paying attention. So hint, hint, test question right here. So this one has two sneaky things in it, two common mistakes. One thing is that it asks you to take this whole polynomial and subtract it from this whole polynomial. So even though it doesn't use it symbolically, you need parentheses to keep the polynomials all together attached. So even though you don't see the symbols, you need them because it's keeping this whole polynomial and taking it from this whole polynomial. So there's the other sneaky thing, from. Remember those words, from and than, made it be backwards. If I asked you to take 3 from 5, you would really write 5 minus 3. The order is backwards. So that means that 2x squared minus 8x minus 4 needs to go in the front, and then the x squared minus 2x plus 1 needs to go in the back. Since I am subtracting, just like the blue one right behind it, I need to distribute that negative. I'm subtracting the whole thing. So that's the second most common mistake, forgetting to flip the order and then forgetting to distribute this sign. So remember, take that time, write it out one more time. It doesn't hurt you. Just do it because I said so, because I want you to get it right. So right here, when I distribute this negative, this would now be a positive 2x minus 1. Write that out. Now I'm going to combine those like terms. I've got 2x squareds minus one of them. Leave me with 1x squared, 8x and 2x. Remember, the sign belongs to the number behind it, so it'd be a negative 8 plus 2 would make a negative 6. And then minus 4 minus another 1 Careful of those negatives, they're sneaky. We'll make a -5. Again, it is an expression, you cannot solve it. That's as far as you can go. So there's 2 mistakes. So make yourself a little note, a star or something, the from that made it be backwards. And then these 2 signs right here, that's where the common mistakes are. Really watch yourself on those signs. Don't forget to distribute. So next, let's step up to multiplying. Adding and subtracting, we just combine like terms, being careful to distribute a negative when necessary. We said that those like terms never changed. It stayed apples. Into the 8th was always into the 8th. But if we are multiplying, now we are multiplying, it does change our exponents. We have to be careful. So we have to distribute that multiplication over addition and subtraction, just like we have in the past. But of course, our terms are a little bit hairier now, so we gotta be careful. If I took 2xy cubed times 4x squared, be careful about the difference of base numbers and exponents. Don't get those rules mixed together. So regular base number 2 times regular base number 4 would make regular number 8. 2 times 4 is 8. If I had 1x in this term, and I'm putting it together with these 2 x's, that would give me a total of 3 x's. 1 plus 2 is 3. I was adding the exponents for a multiplication. If I had y cubed and there's no new y's, it would stay y cubed. Next, I would go 2xy cubed times 2xy. 2 times 2 would make 4. Make sure to put that plus sign there to separate them. 1x here and 1 more x there would make x squared. 3 y's here and 1 more would make y to the 4th. And then last, 2xy cubed times 3y squared. 2 times 3 makes 6. There's no new x's, so it would just stay x. 3 y's here and 3 more y's there would make 5 y's total. Careful, don't multiply your exponents. Power to a power you multiply. This one you're combining. Some y's and some more y's. Add them together. So that was how we would distribute a monomial over a polynomial. We would just take it to each. But what about if you have a binomial to a binomial? You've probably heard in the past the acronym FOIL. There's actually a little bit of mathematical controversy around the word FOIL. Some math teachers are very, very against it. I'm not one of those, I don't mind it. I use it kind of casually as just a word that means multiply polynomials together, even though technically that's not what it means. It's an acronym that stands for first, outer, inner, last. But basically it's just reminding you that you have to make sure that you get everybody to everybody. So in an example like this, if I had 5x plus 8 times 4x plus 2, you can think of it as kind of a 2-by-2 chart. The 5x needs to go to both the 4x and the 2, and the 8 also needs to go to the 4x and the 2. So if I kind of looked at it as a box, like the width and the length, the 5x to the 4x would make 20x squared. The 5x to the 2, 5 times 2 would be 10, and there, of course, was still an x. The 8 times the 4x would be 32x. And then last, the constant 8 times the constant 2 would make just the number 16. Now, I don't necessarily recommend working it out this way. This is just kind of a visual to show you why we end up with these 4 separate terms. So when I'm finishing this up, I see that my like terms would just be these 2 right here. So the final answer would be that 20x squared. 32 and 10 more would make 42. And then of course that constant 16. But instead I think of it more with kind of like these rainbows here and just make sure that everybody goes to everybody. So let's try it that way, more as that acronym FOIL. First, outer, inner, last. First, outer to outer, inner to inner, and last to last. So I'm going to take the 5 to both the 4 and the 2t. 5 times 4 is 20. 5 times 2t is 10t. 10's like 16 sometimes, you gotta be careful. 10t, and he's good. Now I'm gonna take this -3 to both. Be careful, remember the sign belongs to the number behind it, so I'm distributing not just 3t, but -3t. Negative 3t times 4 would be negative 12t. Negative 3t times positive 2t would be negative 6t squared. So these are the only like terms. My final step is to simplify as much as possible so these guys can come together as negative 2t minus 6t squared. Positive 10 minus 12 would make negative 2, which means this is my final answer right here. Now, if you did have one of those picky math teachers in the past, they may have asked you to rewrite this problem in descending order. I am not one of those. I'm just as happy with that circled answer right above. But if you do this, just be careful that you keep the signs with the number behind it. So when you're rearranging, make sure that this negative stays with the 6. This negative stays with the 2, which means this 20 in the front was a positive. So just be careful. So there are a few special cases. Sometimes you'll see them as a separate little rule. But I don't necessarily like to think of them as a rule because they work out exactly the same. If we go through and start foiling, distributing everything, it just works itself out. So in this case right here, if I start in on my foiling, first, outer, inner, and last, 2a times 2a would make 2a squared. 2a times negative 3b would make negative 6ab. 3b times 2a would make 6ab positive, and 3b times negative 3b would make negative 9b squared. Now real quick, you may be asking yourself why I didn't say 6ba. Now remember the commutative property says that since they're all being multiplied, I can swap the order. So all I did is I put it in alphabetical order instead of ba because that helps me match things up a little bit easier. Also notice in these last few problems, the only ones that are matching up are in the middle. If you see anything other than the middle terms matching up, go double check your work because it's very rare that the outside ones would combine as a similar term. More than likely you made one of these mistakes where either in this problem right here you forgot that the last term was a square and then accidentally combined it, or sometimes I'll see where people accidentally think when they're adding and subtracting these should be a square, and then they accidentally combine these two. So just a heads up, if you ever see the front or the back combining, it's more than likely a mistake. So instead on these two, I see a negative 6 plus a 6. So remember that 6 minus 6 is 0. So that doesn't mean there's an AB there. That means it's completely gone. Because if I wrote AB, that would indicate that there's one of them. And there's not one of them, there's none of them, there's 0. So that means the final answer to this problem is, oh, I'm sorry, I made a mistake. This was a 4. 2 times 2 is 4. So you gotta watch out. Get so focused on the details sometimes you miss little things. See, it happens to the best of us. Never feel bad about making mistakes. It happens. So right there, when I double checked my numbers, 2 times 2 is 4a squared minus 9b squared. So this right here is what they call the difference of squares because I have a perfect square in the front and a perfect square in the back, which was this special case that only occurs in a situation like this, where the front guys match, the back guys match, and I have opposite signs, one plus and one minus. The order is not important. Notice that this one had a plus in the front, a minus in the back. It's just that there's one of each. That's the only possible way for this situation to occur where those middle terms were completely canceled. So if you had the same signs, either both pluses, which would make positive 6, and of course doesn't cancel, or both negatives, if they were both negatives, I would have minus 6 and a minus 6, which doesn't cancel. Remember that that would make a negative 12. So the only possible way to make those middle terms cancel is in this situation where you have one as a plus and one as a minus. Matching fronts, matching backs, one plus, one minus. So it's the special case, and we're going to see that a whole lot more when we get to a later section of factoring. So on that note, when we go to this problem right here, be careful. There's a really common mistake to think that it is 25x squared plus 4y squared. But please do not make that mistake. Every time you make that mistake, a puppy dies. So don't do it. It's not that answer. Okay, so don't fall for their tricks. So when it's saying that 5x plus 2y is squared, it's saying that there's actually two 5x plus 2y's being multiplied together. So remember, a square just meant repeated multiplication. So here I have a multiplication of a 5x plus 2y times another matching 5x plus 2y. So it's repeated multiplication. I can't just distribute the two. It seems like we could have. You might even think, oh, she just told us there was a rule about that. But remember, the rule was, right here, it was if they were multiplied together in the parentheses. That was when I can distribute that exponent. Because then when I was multiplying, I just literally had 3 of the a's and 3 of the b's. So this one is different because it has a plus or minus sign inside. So it's not just a 5x squared and a 2y squared. So because of that plus or minus, I actually have to FOIL it out. So I do get a 25x squared. That is part of my answer, but I have to remember that I also have the outer and the inner. So that's going to give me a 10xy, and then 2y times 5x would give me another 10xy. And like I was saying, no matter what happens here, they would have the same signs, not opposite like the purple one right above. So my last times last would give me a 4y squared. So anytime you have a binomial squared, plus or minus anything, if you ever have two terms squared, you will always, always, always end up with a final answer of 3 terms, always. The two will always combine, and you will never, ever get them to cancel, because the only way to make them cancel was with a plus and a minus, and if you're squaring it, they will have the same, not opposite. So we will always, always, always get 3 terms. A binomial squared, no matter what, plus or minus anything, binomial squared always has an answer with 3 terms, always. So if you put that in your brain, it will help you avoid this mistake that kills the puppies. So don't do it. All right, so part of the reason that some math teachers dislike the acronym FOIL is because technically it only works for the binomial times the binomial, first, outer, inner, last. Like I said, I kind of hazardly, I guess, misuse it just to mean multiply polynomials, which is what most people do. So technically it would not work in this case, but the idea behind it does, that everybody goes to everybody. So even though there's not enough letters in the acronym to get every case of this one, like I said, the idea behind it is still there. So the x needs to go to the x squared, the 3xy, and the 9y squared. The negative 3y needs to go to the x squared, the 3xy, and the 9y squared. So I'm actually going to end up with 6 separate terms, 6 multiplications, 6 separate terms. So I tell myself that going in because this problem gets a little bit long, maybe a little bit intimidating, so I can kind of check myself after this first step. So let's get going. X times x squared would make x to the third, 3 x's. X times 3xy would be 3x squared y. There's 1 x here and 1 more there, 2 x's. X times the 9y squared would be 9xy squared. This x combined with those 2 y's. Going in here, be careful again that that negative stays with the 3. So minus 3y times x squared would be minus 3x squared y. If you wrote yx squared, you're not wrong, but like I said, I like them in alphabetical order. It makes it easier for me to match things up later. Just be careful that the x was the squared one and the y was single. So make sure that x stays with the square. Next, I go minus 3 times positive 3 would make a minus 9. Y times xy would make xy squared, 2 y's. Last, negative 3 times positive 9 would make negative 27. 1 y here and 2 more there would make y cubed. Okay, 1, 2, 3, 4, 5, 6 terms. These 3 from the first guy distributing, these 3 from the second guy distributing. It also can be a good idea at this step just to kind of double check your signs. Minus times plus was minus, minus times plus was minus, minus times plus was minus. Just a good place to kind of stop and check yourself. Now I'm going to start combining, and just like I told you up here, you should never see the front or the back guy combine. It's very, very rare that that should happen, and it's usually because you kind of did a multiplication out of order. So if you did things in order, they should never ever combine. Here's my x cubed. There's no other x cubes. Next I see this one has 2 x's and 1 y, x squared and 1 y. So even though this one has x's and y's, he has 1 x and 2 y's. He is not a like term with this right here. Skip to the next one. He has 2 x's and 1 y, just like this one. So they match up. Positive 3 minus 3 would completely cancel. So that means these terms actually completely disappear. The final answer will not have any more x squared y's. Next I see the 9xy squared matches up not with x squared y, but with this other xy squared. So those guys again would completely cancel. 9 minus 9 is gone, it's 0. So the final answer to this FOIL problem, this multiplication problem, would actually just be this difference of cubes, which is another special case which you might see more about in a later math class. Don't worry about it too much right now, but here's the special layout for things that would cancel all the middle terms for a difference of cubes. Okay, now if you were dividing polynomials, you have to be careful if you're dividing by a single term monomial, like these three, or if you're dividing by a plus or minus polynomial, so something with a plus or minus in it, like this. If you have that plus or minus, things get quite a bit trickier. It involves long division, which we're not going to cover in this class. So luckily, all of these are divided by a single monomial, which is that short division. So in this one right here, if I'm doing short division, then all I have to do is I rewrite the top, 10x plus 40y, and I put each one individually over that denominator of 5. Our order of operations would tell us to combine all of this stuff on the top as a grouping before I do that step of division. Since I don't know the x and the y, I'm not able to do that, so instead I have to break it apart so each one individually gets its own separate division. And now I can look at them one at a time and break it down into 10 divided by 5 is 2, and 40 divided by 5 is 8. And that would be the answer. That's as far as we can go. So let's do the same on this one. Rewrite the top, and again, it may seem tedious, but please do it because I say so, because I have lots of experience in math and common mistakes, and I know that this really helps out. So write it again and put each one individually over that denominator of 3x. If you try to do stuff in your head and do some of this stuff, you're going to accidentally double cancel, and then you'll mess something up. So please write it out just like I do here. Then you can focus one at a time. Positive 12 divided by negative 3 is negative 4. This x and this x match up and cancel out, leaving only the y squared. Over here, now I can see that it was actually negative divided by negative is positive. 27 divided by 3 is 9, and both of those x's would cancel. So this right here is my answer. Now this one again, take that time, write it out. I promise it's worth it. It's going to save you some test problems, especially in this one. This is the hardest one of the batch. Put him here because he's sneaky. Now just to emphasize what we've been learning so far, I'm going to do this one backwards. You don't have to do this one backwards when you're working it, but I wanted to point something out. So I'm going to start with the last term here. In the last one, I have negative 16 divided by 16, which would completely cancel. The number part would go away, it would cancel out. Negative divided by negative is positive, and then 7 x's on the top and 3 x's on the bottom has more x's on the top than the bottom. If 3 out of those 7 cancel, that would leave me 4 x's on the top. more x's on top or than the bottom. So like if you visualized it, you would see all 7 of those x's. Run out of room there. And 3 of them would go away, leaving me those 4 on the top. Okay, but the reason I started there is that was the easiest term of the batch. This middle one, negative divided by negative, is positive, but 18 divided by 16 is not an even integer fraction. So instead it does reduce, and you can use your calculator if you have trouble with fractions at all. So you could just type it in, hit that math enter, and it would show you that it reduces to the fraction 9/8. Okay. These x cubes completely match up, so just like they did right here, they would completely cancel and leave only the fraction 9/8. Notice that each of these terms needs to be separated by a plus or minus sign, so if I'd not written this plus right here, it would have looked like it was 9/8 x to the 4th, and that's not what I want. They're separate. All right, last one, positive divided by negative is negative. Again, the fraction does not completely cancel, so this would be 7/8. And here's the sneakiest part. This one has more x's on the bottom than the top. So of these 3 x's on the bottom, 2 of them would cancel out, and that would leave me with 1 x on the bottom. Now you have to be very careful to write it so it will show up on the bottom. So on XYZ, that means you're going to need to either use that little yellow arrow, or you would have to type it in like this, where the -7 is divided by parentheses 8x. If you don't use the parentheses or the little yellow arrow, if you write it in like this, here's what the computer sees. It sees 7/8 x. And if you have an x over to the side like that, that implies that it's on the top. So this right here would be the same as 7x over 8. So the only way to show that it's in the bottom is to indicate all the way with the line that it's on the bottom. If he's off to the side, that indicates that it's on the top, which is not what you wanted. So don't do that. Be extra careful. Okay, so I see that a lot in this problem. Be very, very careful, especially on XYZ. All right, so the last little bit of this lesson, we're going to use these properties that we've been practicing and work our way backwards to solve. So all of these, I was saying it was just an expression, we couldn't solve them yet. So now let's take it one step farther and solve it. So on this one right here, if I told you that I squared a number and got the answer of 9, you would probably tell me that that number must have been a 3. Now you're not wrong, but you're only half right. There's one more number that I can square and get the answer of 9. 3 squared is 9, but also -3. Because remember, -3 squared means that it's negative times negative, which is in fact a positive 9. So both of these answers are true. The y that would make this work is both a 3 and a -3. This right here, this power of 2, indicates that there will be 2 answers. It will be the number of the highest power here. 2 answers, positive and -3. So what happens is when we square root to undo this square, remember those are the backwards, the square root and the square cancel, because if I square root, remember that that is the same as the power of 1/2, b to the power of 1/2. So if I put a 2y squared over a half, you would have 2 over 2, which cancels out. The square root and the square cancel. So I square root both sides to get my answer, but the square root property says that when you do that, you have to introduce the plus or minus, because just like we saw here, both the positive and the negative numbers square out the same. They both square out to become that same positive 9. So when you square root both sides, you need a plus or minus. Okay, let's try it again. So on this one right here, we've got a little bit of work ahead of us. we see that we have an x squared, but just like an algebra problem, first I need to get him by himself, kind of solve it out, just like if it had been just a regular x. Kind of big numbers, but we got this, don't get scared. That would give me a 625. But then I divide it by that 25. And that gives me 25. 625 divided by 25 is 25. Now here it is again, that square. To undo a square, I square root. But when I square root, I have to do that plus or minus. And the square root of 25 is 5. So there's my two answers. I knew there was going to be 2 because it was an x squared. It was both a 5 and a negative 5, because negative 5 squared is the same 25. Now these were both nice pretty numbers, but they won't always be quite as pretty. So this one again, I would square root both sides, but if you typed a square root of 25 in your calculator, it gives you the pretty number 5. If you type in the square root of 12 in your calculator, it's going to give you a crazy decimal. So what we have to do is use our square root principles that we were learning in section 1 or 2, back before, just to clean this up, to reduce this square root. So if I break down that 12 into his primes, I know that it's 2 times 6, which is 2 times 3. So I do have that pair of 2's, and then that standalone single 3. So that means the final answer for this one would be either positive 2 square root of 3 or negative 2 square root of 3. Okay, so this one is kind of like the red one. It's got 2 steps involved. So let's see. If I did my positive 20, my plus 20 first, 0 plus 20 is 20. And then I would divide by the 25, which is a messy fraction, but it does reduce. That would give me 4 over 5. And don't worry, when I square root both sides, I don't have to worry about what fraction it would be. I'm just going to leave it right there. All I have to remember is that it would have a plus or minus. Square root of 4/5. Oops, sorry. 4 over 5. And you can leave it right there. There's a technicality about rationalizing the denominator. Don't worry about it. Just right there. That's all you need. Okay. Now, all of these ended up as the plus or minus of that number, but be careful. Don't get on a trend. It's not always just plus or minus the number. It was the fact that the square root principle told us that both the positive and the negative numbers squared give us the same answer. So in problems like these, last 4 right here, I have stuff squared. Now I could FOIL this out and try to solve it, and there's another way, but we're not learning about that one just yet. So instead, we're going to keep using our square root principle. We're going to square root both sides, just like we did with the regular little number. And we're going to throw in that plus or minus. So the square root and the square cancel out and leave me just that inside stuff, y plus 4. And then over here, I have to remember that it was plus or minus that square root of 81. So what this means is I actually have 2 separate scenarios, 2 separate little baby algebra problems that I need to solve. The square root of 81 was 9, which means either the inside stuff, y plus 4, was equal to 9. That's the more obvious one, but the sneaky one is that maybe that inside y plus 4 was equal to the negative 9. I have to think through both cases, the positive or the negative, plus or minus. Notice that in both of these, it's the same y plus 4. I never changed the stuff. Stuff squared, y plus 4, y plus 4. It was the other side, plus or minus the square root of the 81. And now I just finished solving. As I finish solving, notice that they both have the same steps. I'm minus 4 from both of them, which means that the 2 numbers that would make this happen would either be 5 or negative 13. That might seem weird. It might seem like it should have been plus or minus 5. So let's look real quick. Remember that you can check your answer for any algebra problem by plugging it in. 5 plus 4 would make 9. 9 squared is 81. So that one works out. This is the one that seems a little sneakier. It seems like maybe it should have been a minus 5, but let's look at that real quick. Minus 5 plus 4 would be negative 1. Negative 1 squared is not 81. So even though it seems like this should have been the answer, it is not. It did not work out. But negative 13 plus 4 would be a negative 9. And negative 9 in parentheses squared does make 81. So this one checks out. Okay. Same thing here. I've got stuff squared. So I'm going to square root the stuff. The stuff never changes. It's this over here, the plus or minus. So I've got either 3y plus 4 is equal to, remember square root of 25 is 5, so it could be equal to the positive 5. But maybe that 3y plus 4 was equal to minus the square root of 25, be a minus 5, plus or minus. Okay, now as I'm solving, again notice that I do the same steps to both. The stuff has never changed, always the same stuff. So I get that 3y is either equal to 1 or 3y is equal to negative 9. Careful of those signs. And then the last step for everyone is to divide by 3. So I either have the fraction 1/3 or I have 9 divided by 3 is 3. Negative divided by positive is negative. And again, if I was concerned, I could plug these back in to double check. 1/3 times 3 would be 1. 1 plus 4 is 5. 5 squared is 25. Negative 3 times 3 would be negative 9. Negative 9 plus 4 would be negative 5. Negative 5 squared is 25. It all checks out. So I start this one. It looks like it's the same as the one right before. But right here, on all of these, we kind of knew off the top of our head square root of 25 was 5. If I wasn't great with my perfect squares, I could have plugged it into the calculator. But this one, when I square root to cancel, right here, I would get plus or minus, but then I'd have the square root of that negative 4. Now the square root of 4 is 2, so you might think this would be a negative 2. But remember that 2 squared is 4, and negative 2 squared is also 4. There's absolutely no number that would make a square of negative 4. Because either the positive or the negative would have canceled. So there's nothing that would square and make a negative 4. That means there's no way I could square this right here, this stuff, and end out with a negative 4. So the final answer to this problem is does not exist. There's no way I could square something and end up with a negative. I would confirm this just for regular working the problem when I got to this step and tried to type in the square root of negative 4 on my calculator. Because as soon as I hit enter, it gives me that error. So the square root of negative 4 pops up and says non-real solution. Doesn't work. Okay. One more on this slide, this word problem here. I know everybody loves word problems, but remember, don't panic. First step, the square of the sum of a number and 3. Now, if you remember in the problems like this, I said all of the kind of casual words, twice, double, things like that, were a multiplication. So the only way to show a power like this one is to pretty specifically say power, square, something like that. So I know a square is one of these little guys, but it's saying to square not just the number, but the sum of the number and 3. That means it wants you to take the sum first and then square it. So I need those parentheses. The square of the sum of a number and 3 is 36. Now it looks just like all these problems, so let's try it out. So just like the others, I would square root both sides to cancel that square. That's going to give me the stuff is of course either equal to positive 6, the square root of 36 is 6, or maybe that stuff was equal to the negative 6, because negative 6 squared is also 36. So we'll finish solving this relatively easy algebra problem. Remember, you should be seeing the same steps on both for the two final answers of positive 3 or negative 9. And you can check even this with the word problem. The sum of the square of 3 and 3. 3 and 3 is 6, squared is 36. The sum of the, sorry, I'm said it backwards. The square of the sum of 3 and 3. The square of the sum of negative 9 and 3. Well, the sum of negative 9 and 3 would be negative 6. Negative 6 squared would still be 36. I can still check my answers. One last slide, we're almost there. Now, even though they look kind of scary, these are actually easier. When you were squaring, like I said, you know, we have this kind of sneaky number that's snuck in there right there, the plus or minus. But to undo a square root, just like you would probably expect, we would square both sides to make them cancel. So since I undid a square by square rooting, I can undo a square root by squaring. Now when I do this, when I square both sides, every once in a while, in a pretty rare case, I can accidentally kind of magically introduce a false answer. So even though I worked it out perfectly, just mathematically the way numbers work, a wrong answer might have snuck in there from the fact that the negative squared makes the same number. So because of that, in these problems, you absolutely have to check your answer. So you always should. It's always a good idea. Sorry, writing on a tablet is tricky. But on these especially, you want to check. You need to check your answer. Okay, so we're going to do that on every problem. So first off, I square both sides. Square root and the square cancel. Be careful, it does not change the stuff. It's not 4 and 9. It's the square root squared cancels to just the inside stuff, 2a plus 3. Sorry, my 2a looks funny there. Let me rewrite it. There we go. And then over here on the right, 3 squared is 9. I don't have to do that plus or minus thing because I'm squaring them. So then I go through my normal solve steps. I don't have to worry about doing it twice like those other ones. It's comparatively easy. Divide by 2 to see that the variable a should be 3. But like I said, we need to double check. So I just plug it in. I can do it, you know, in the calculator in my head. I don't even have to write it down. 2 times 3 is 6. 6 plus 3 would make 9. And sure enough, the square root of 9 is 3. So it checks out. Okay. So let's do the same over here. First, I'm going to square both sides. Remember, I don't change the stuff. The square root of the stuff squared is just the stuff. Over here, 6 squared is 36. And now I can go through my normal solve. Be 42 divided by 7 is 6. Okay, let's double check. 7 times 6 is 42. 42 minus 6 is 36. Square root of 36 is 6. Checks out. Careful. Always check those. Now this one here has a loose number. So notice how the square root stops right here after the 1, and this 3 is not under the square root. So that means if I tried to square both sides right now, technically I would have to FOIL things because I would have 2 terms inside. So you don't want to do that. The easiest way to fix this is to go ahead and get this loose 3 that's not trapped under the square root over here away with a nice loose 6. So that gives me that the square root of 4x plus 1 is equal to 3. And now I can square both sides. So I need to get my square root all by itself first before I square it. And then the square root and square cancel and leave me just the stuff. 3 squared is 9. And then finish solving just like regular. Give me 4x equals 8 divided by that 4 would make 2. Let's just double check. Always a good idea. Extra careful here. 4 times 2 is 8, plus 1 is 9, square root of 9 is 3. 3 plus 3 is 6. Checks out. Okay, so it's those even, the square roots and power of 4, the ones that you have to be careful of, because anything raised to an even power cancels out the negatives and always turns out positive. So these down here are cube roots. So you may already know, to cancel that cube root, we would have to cube it. A square root squared cancels, a cube root cube cancels. Because remember, if I had the cubed root of x, it would be the same as x to the 1/3. So if I cubed a cubic, that would be 3 over 3 would cancel to just a x. So I'm going to cube both sides. That again is going to keep the inside stuff the same. It just cancels the cube root and the cube. Over here, be careful, that is not 6. 2 cubed is 2 times 2 times 2 is 8. And now I can solve. It's all loose away from the root. So that would give me a 2y equals 14 divided by 2 would make 7. Now, it's always a good idea to check, but it's not as essential in the cube roots because a negative cubed is a negative. Negative 2 cubed is negative 2 times negative 2 times negative 2, which is negative 8. So negatives can occur with odd roots, which means that if I took the cubed root of negative 8, I get a negative 2. Okay, so negatives are not as tricky with the odd powers. So on this one right here, when I cube both sides, I don't have to be worried about this negative like I was with the square roots. It works itself out. Cube roots are okay. So this would give me the 4x minus 8, cancels out of that cubed root. Be careful, this is not 12. 4 times 4 times 4 is 64. Negative times negative times negative is negative. So the numbers get a little big here, but we got this. Keep your calculator handy. This one gives me that 4x equals 56. And 56 divided by 4 makes 14. Negative divided by positive is negative. Okay, so always a good idea to check answers. If I wanted to, I would say 4 times 14. Double check that would be 56, of course, and then 56, or negative 56, sorry, minus another 8 would make it negative 64. The cubed root of negative 64 is negative 4. So we can always double check. Okay, this one here, I've got a 4th root, so I do need to be careful about positives and negatives. I'm going to want to double check this answer. But a 4th root to the 4th will cancel. So that's going to leave me this stuff, 3a minus 2. 2 to the 4th, 2 times 2 times 2 times 2 is 16. And my 2 gives me 18. Divided by 3 makes 6. Okay, since it was an even root, let's just double check things. 3 times 6 is 18. 18 minus 2 is 16. The 4th root of 16 is 2. Just like we said, 2 to the 4th is 16. So it works out. Now this one right here, I have a square root equals a square root. I would need to be a little bit careful about any crazy signs going on, but basically, since these have to end up as positives, and these also have to end up as positives, it works itself out. So when I square both sides, to cancel the square root on this side, it also cancels the square root on this side, which means that it's really just that 2y minus 2 equal to the 4 minus y. Now I solve like normal. Now I know it's been a minute since we did one with letters on both sides, but remember you need to get your letters together first. You can't solve for a variable if he's in more than one place. So when I move my letters over here together to the left, I get 3y minus 2 equals 4. You don't want to start moving your numbers around until you know which way you need to move them. Otherwise, you may end up just putting yourself in circles. So now I know I need to move that 2 over there to the right with the 4. And then last, divide by the 3. Oops, 3. And that gives me my y is 2. Since there were square roots involved, I do want to double check this just in case. 2 times 2 is 4. 4 minus 2 is 2. Give me the square root of 2. 4 minus 2 is 2. This also gives me the square root of 2. That doesn't mean the answer is square root of 2. That means they came out to be equal, which means this is the correct answer. So I don't even have to know what the square root of 2 is. I just wanted them to match. It meant that this side was equal to this side. Okay, same story here. They're cube roots, so I'm even less concerned about the signs. It's going to work itself out. Cube root cube will cancel, which means the inside 3y plus 6 is going to equal this inside 13 minus 4y. Again, make sure you get your letters together before you start solving. Add 4y to both sides. That's going to give me 7y's. And now I know that I need to move the 6, not the 13, to get my y by itself. That gives me a 7, which divided by the 7 next to the y means that the y is going to be 1. And just for extra carefulness, let's go double check. 3 times 1 is 3, plus 6 is 9, so we end up with the cube root of 9. Don't worry, I don't even have to know what that is, as long as it matches over here. 4 times 1 is 4, 13 minus 4 is the same 9. So the answer is not the cube root of 9. The answer of 1 is confirmed because this side equals this side. Okay, and that is all of chapter 4. As always, please let me know any questions that you have.